Hello all, I am here to explain you what is extreme programming. So I'll just begin with the introduction. So extreme programming is nothing but uh, a model which is coming under agile programming models. So, extreme programming, as the name suggests, is something extreme we are going to do where we don't give focus at all to planning, designing, and all those. Our major aim is to provide the best solution for our customer in the best time. So that is what our major aim is. So in extreme programming, as you can see in the screen which I have shared, there are three different phases: XP design, XP coding, and XP testing. Only three phases. So design, as I don't have to explain much about design because you have seen a lot of detailed aspects of design phase of software engineering. And coding also, it's just design phase will give you a proper design for your chunk, and then you will go for coding. So XP stands for extreme programming. So only differences I have mentioned in the slide which I'll be explaining you. So the basic phases are design, coding, and testing. XP design, XP coding, and XP testing. And under XP design, we'll just see the few keywords that we are going to use in XP design. So, as you can see in the first point, it follows KIS principle. What is KIS principle? It's already given the expansion, that is, keep it simple. So that is what we are trying to do. So earlier it was like, if you go for complicated problem solving, definitely you will have a better solution. But maybe in our right now, what the customer demand is the simplest solution they can have, so that later on if they want to change, it is not going to be a headache for them. And another thing is, if it is simple, definitely we can deliver the outcome as early as possible. So that is the first major principle that we are going to follow in extreme programming, that is, keep it simple. Second one is encourage the use of CRC cards. It sounds a little physical stuff, but still it is very useful. CRC card stands for class responsibility collaborators. So here it is something very similar to class diagram we have already learned in Java, C++, and all object oriented programming languages. You might have already learned about class diagrams, where we have the class name, visibility, the attributes of your class, the methods of your belonging to your class, the variables, class members, data members belonging to your class. So just like that, so class diagram will give you all those information: the visibility of each method, visibility of your data members, the arguments. That is just like the skeleton of your class will be given in your class diagram. So just like that, the CRC cards are physical cards wherein you have all these three information, that is class, responsibility, and collaborators. I'll just show you one sample class responsibility class collaborator card, where you can see the class name will be mentioned, and you have two columns, that is responsibility and collaborator. Responsibility gives the information about the responsibility of the particular class. So every class will have its own role and responsibility. So what is the expectation from that particular class will be mentioned under the responsibility column, and collaborator column will give you an information about all the other classes that is going to collaborate with this class, or the dependency or relationship, you can say. So all those things will be mentioned in your collaborator. So this is an example of your class responsibility collaborator classes, sorry, cards. So this particular stuff is going to help us to track all the classes that is going to be there in your deliverable for the particular iteration. And we are clear about the classes responsibility and classes collaborators. So all these three things very clearly everybody will be aware about. So that is the use of CRC cards. And the next keyword, which is very relevant in XP design, is spike solutions. So I hope you understand what is spike solution. It is a very quick research that we conduct for learning some or solving some complicated issues in very short time. So it is a very quick research that or quick solution that you're going to find out. So that is called as spike solution. So we don't go for a very long. So what is the difference? So normally for the conventional models, we take a lot of time. We spend a lot of time for researching and finding out the best solution. Here we are not going to give them the best solution. It may be simple, but it should be quick. So that is why we go for spike solution. So it is also a design prototype. And the fourth and last one is refactoring, which we encourage refactoring, which is an iterative refinement of the internal program design. So refactoring is one phase of the design stage where we go through the design again and again and just refine it, because we are trying to do finish everything quickly. Maybe might be some or the other flaws, so we are trying to refine the design by doing the refactoring. And the next one is XP coding, where you can see the two important keywords that we use in coding is recommends the construction of a unit test before coding commences. Normally, we do it parallelly. So every programmer or the person who is doing coding will be doing the unit testing parallelly along with the coding phase. So here we have to construct the unit test cases, and everything should be ready uh, before you start with the coding phase. So that is one major difference between the XP coding and the other conventional models coding phase. And the second keyword is pair programming, where we will be normally everybody does their own part individually. So here we will be having a pair who is doing the programming part, where the pair will be one who is the driver and another one who is the navigator, and where somebody is guiding us for solving the errors. So it's uh, all these arrangements are to make the activities completed quickly. So if somebody is there who is sitting as a supporter for finding out how to execute something which we are not very confident on, or if you have a bug, to clear out the bug, if two people are sitting, it'll be easy, it'll be faster when compared to one person whoever has coded and sitting and debugging it. So that is the two keywords that is there in XP coding. In XP testing, apart from all the normal testing procedures, we have unit test executed on a daily basis. So whenever we do programming, it will be undergoing the unit test process also. And the acceptance tests are defined by the customer and executed to assess the customer's visible functionality, which will be done in every increment. So these are the key points that you have to take care, remember, when you are talking about extreme programming. So this is the architecture, we can say, which very suitable architecture for extreme programming, where we start with this very small planning. User stories will be taken, and that stories will be converted into the deliverables. And when soon after the planning, we will start with the design phase, where we have to have the CRC cards along with small spike solutions. Prototypes will be there. And design phase, soon after design phase, we will start with coding, and where we do the refactoring again and again, reframing the like going through the code and refining the code is going to happen. And we have pair programming when the coding phase is happening, and continuous integration is also happening while the coding phase is on. And soon after coding, we'll go for testing, where unit test will be conducted on a daily basis, and acceptance testing will be organized, or it will be done by the customer. And finally, at the end of this cycle, you will be delivering the software increment, which will be uh, executable. So, with that, I would like to conclude the extreme programming architecture and the few important keywords which we use in different phases. Thank you for watching, and I hope it was useful for you.